Hello and welcome back everyone. We're going to take a look at another application of logarithmic functions, and we're going to take them to the field of chemistry to help us understand the concept of pH. So to measure pH, which by the way is a way of measuring how acidic a solution is, we use the logarithmic functions. So what is pH? pH actually describes the number of hydrogen ions in a liquid. So the more hydrogen ions in a liquid, the more acidic the solution is. And pH is actually a system that describes how acidic a solution is by simply taking into consideration the concentration of hydrogen ions. So in this system, the pH of 1 will describe the most acidic solution, and a pH of 14 will describe the least acidic solution. And right here in the middle, we have the pH of 7, which is considered to describe the neutral solutions. Now, imagine that you have a small volume, let's say, of 50 milliliters of a solution. And I assure you that you can have a volume of 50 milliliters with, let's say, for example, 100,000 ions. And that's not even going to be a big number or exaggerated numbers. So that is a very big number in itself. So to describe the acidity of a solution just by using the concentration of hydrogen ions can be a little bit awkward due to the big number of ions that are in a small solution, a small volume. So in order to avoid using such big numbers to describe the concentration of hydrogen ions, one of the physicists, his name was Avogadro, I don't know if I'm pronouncing it correct, but it's not English anyways. So he used a different concept. So he said, well, I'm going to let 6.02 times 10 to the power of 23 atoms. And remember, atoms, ions, means the same thing because ions do come from atoms removed one electron. So that would be equal to 1 mole. That's a decision he made, okay? So if you have 100,000 ions in a solution, how many moles would you have? So you're going to have 100,000 divided by 6.02 times 10 to the power of 23. If I use the calculator here, then I would get 100,000 divided by 6.02 times 10 to the power of 23, right? So that would give us a very big exponential, very small exponential number. I meant to say very big exponent. So 1.661 times 10 to the negative 19. So this would be 1.66 times 10 to the power negative 19. So notice how we got an exponential here with a negative sign and then, all right? So the number of moles that describes the number of moles in here that describes the concentration of hydrogen ions, it has a negative exponent because that would be a small, these number of moles here would be a small fraction of 6.02 times 10 to the power of 23. So that's the reason why the pH formula, which is right here, by the way, waiting for us to pay more attention to, has a negative sign before it. Okay, so that we can describe pH with positive rather than negative numbers because negative numbers can be confusing. Another version of it would be pH equals log with base 10 of 1 over h. So it's the same thing. Okay, so we're going to take a look at a couple of examples together. They're not too difficult. I hope that the formula, the explanation of the formula made some sense. If you have more questions, just shoot me an email and I will be very happy to talk more about it. We have to find the pH of a swimming pool with hydrogen ion concentration of 6.1 times 10 to the negative 8 moles per liter. I just want to emphasize again how we use the negative exponents in order to describe the concentrations, right? So we're simply going to write the concentration of hydrogen ions given 6.1 times 10 to the negative 8, And we need to find pH, that's our unknown. And we'll say that pH is the negative log of the concentration H plus. That's just a formula, so negative log of 6.1 times 10 to the power of negative 8. And we'll ask the calculator what this number would equal. So log of 6.1 times 10 to the power of negative 8 will give us negative 7.2. And negative 7.2 with the negative sign in front of it will give 7.2. So pH of this pool would be 7.2. Okay, so the next question, example 5, says that the pH of fruit juice is 3.10. What's the hydrogen ion concentration to the fruit juice? So this time we are looking for H plus. And we know the pH to be 3.10. Remember, pH is usually going to be described by numbers to decimal places, but this was kind of a nice number around it, so that's why I just left it to 1 decimal here. So not that big a deal for now. And again, we're going to start by writing the formula. pH equals negative log of the concentration H plus. pH of 3.10 is negative log of H plus. Divide both sides by a negative 1 here. And we'll say that negative 3.1 equals log of H plus. And that will make the concentration of H plus equal to 10 to the power negative 3.1. And we'll ask the calculator again what that would equal. So 10 to the power of negative 3.1 equals 0.000794. Okay, so 0.000794. All right, so as you see, it's a very small number, so we're going to say that that would be rounded to, so here I'm writing in scientific notation always because we are doing science here. So we have 1, 2, 3, 4. So 4 decimals means that we're giving 10 to the power of negative 4 here to get to 7.94. Right, so that would be the concentration of H plus. All right, now remember the unit measurement here would be moles per liter. Remember, in 1 mole there is lots and lots and lots of of hydrogen ions. Okay, so this is the answer, and I will box it up very quickly. Again, I hope this made sense. I really wish that you take the time, and hope that you take the time to do the homework. There is only 4 questions that I wanted to do. And again, if you have any questions, just write to me, and we'll talk about it.